internal energy, a rise in temperature, or a change in state can be observed. So as I mentioned, the rise in temperature is related to the rise in kinetic energy. The change in state is related to the rise in potential energy. They are corresponding, don't mix them up. So the higher the temperature of a body, the greater the kinetic energy. Any questions for one? Okay, now we have wax. It is a cooling curve. So as time increases, the temperature goes down because it is cooling. When is it purely a solid? Rs is a solid. How do we know? When they say it is purely, okay, look at these three different options. Part 1, Part 2, Part 3. Part 1 is purely solid. Part 2 is a mixture, solid and liquid. Part 3 is purely solid. Which of these three gives you a change in state? 1, 2, or 3? Which one is there a change in state? Only number 2 is a change in state. Number 1 is purely solid, just solid. Number 3 is pure liquid. And at number 2, we have the solid mixing with the liquid. So there is a change in state over there. And what did I tell you about the change in state from the graph? Which part of the graph shows you a change in state? The horizontal line. Okay, so this is the easy one. There is a change in state here. Then we have to decide, when is it purely a solid? Is it this or this? And when is it a liquid? Is it this or this? Yeah, so we use our common sense, right? Solid, the temperature must be lower. So Rs must be our solid. And the liquid must be PQ. Right, just write S. They ask you to state a portion of the graph, not just one point. So a portion, we break this graph down into 3 portions. Okay? So let's imagine what is happening. At temperature 70 degrees, wax is a liquid. So as time passes, it starts to cool down. Because our room temperature is about 25 to 30, right? So it starts to cool down, losing energy to the surroundings. What changed? Did the kinetic energy change or did the potential energy change? When the temperature starts to go down, which one changed? Kinetic or potential? Kinetic energy changed. It is losing energy to the surroundings. As such, temperature drops. When it is at 50 degrees, something happens. It is called a change in state. Okay? Since the temperature did not change, the kinetic energy doesn't change. So, what changed? Sorry, Junior? Potential energy changed. The potential energy starts to drop at this region. Okay? It is dropping because it is forming bonds. The bonds between the molecules, they are being formed as it is solidifying. So that explains why temperature is constant, but the total energy still drops. And from R to S, it becomes a fully solid already. That's why candles, they are solid state at room temperature. Okay, so the freezing point of wax. What's the freezing point? 50. Freezing point. That is when there is a change in state. From freezing, right, means from a liquid to a solid. Liquid to a solid. This is the temperature where it happens. So again, if I ask you, state the melting point of wax, so what will it be? What do you think is the melting point of wax? Also 50 lah, because that's where we have a mixture of solid and liquid. Okay, so why isn't there a change in temperature in QR? Although thermal energy is released from the molten wax as it cools. So this is the answer. Potential energy between the molecules lost to the surroundings as heat. Copy this down, exactly. This is a very good answer. Okay, do you have everything? What? What do you say? Please know the difference between potential energy and kinetic energy and what they are related to. I'm sure this will come out also, especially the change in state over here versus the drop in temperatures. Okay, so let's test the knowledge. My question is, why does the average kinetic energy remain unchanged? Answer, I said it earlier on already, but let's see whether you remember or not. Why do we say that the average kinetic energy remains unchanged? So take some time to think, and I'll ask. Sydney, why do you think the average kinetic energy remains unchanged? Or how can we prove that? The graph is constant? What does that imply? Temperature is constant. So why do you bring in temperature? Why do you talk about temperature? You're correct so far. I just need to elaborate a little bit more. Okay. So if the temperature doesn't change, it means that the... Yes. So she said that when temperature changes, like in PQ and RS, it means there is a change in the kinetic energy. Correspondingly, temperature goes up, kinetic energy goes up. Temperature goes down, kinetic energy goes down. So when temperature doesn't change, your average kinetic energy also doesn't change. Okay? Next. Now we have something we are more familiar with. H2O. Now we have solid ice at negative 10 degrees Celsius. That's probably the temperature in your freezer. It is below 0 degrees. And it is melted to water at 20 degrees Celsius. So the process over here is, you open the freezer, you take out one ice cube, you put it on the table. Okay? Then we measure the temperature as time increases. So as time increases, the temperature of the original ice cube, initially negative 10, when you took it out from the freezer, it will start to gain or lose heat. Will it gain or lose heat when you place it on the table? It will gain heat. And it is shown by an increase in temperature over here. Meaning, kinetic energy increase or potential energy increase? Kinetic energy increase. So kinetic energy increases, they are vibrating more and more within the ice cube, still about the fixed location, position. Then when it hits 0 degrees Celsius, it is flat. So there is a change in state. What we will observe will be the ice is melting. When we see the ice melting, we see some of it as liquid state, some of it as still a solid state. But the entire ice and the water mixture is at 0 degrees Celsius for pure water. At this point in time, does the kinetic energy increase when it is melting? No, it doesn't. So instead, the potential energy increases. And that is due to the change in state. All the intermolecular bonds, they are being broken. Initially, in a solid, they have strong bonds, right? Then they start to break these bonds. To break the bonds, they need energy. So the surroundings provide it with energy to break those bonds. And it becomes more and more of a liquid. Only at point C to point D, it is fully liquid. And that's when the temperature starts to rise again. So, what are the states of matter for AB? We said already it's ice. What about CD? AB is solid, CD is liquid. What about BC? It's going to be a mixture. And what's the melting point of ice? 0. Okay, what is the freezing point of water? 0 lah. Explain why there's no change in temperature. Okay. So similar phrasing to the previous question. Every point must be in. Say again. Which energy? Heat energy. They're wrong. Thermal energy, okay. Thermal energy is required to overcome the between. Did you say that? Is that all that you said? That you wrote? I want this part as well. Because you only talked about the thermal energy used to break the bonds. But you didn't talk about temperature. See the question they asked you about temperature, you didn't mention anything about it. So your answer was incomplete. Zafan, you are reading now? Exactly like this or in your own words? So fast? Huh? You copied very fast, huh? That, okay, all done? Now we are moving on to 9b. Okay, boiling and condensation, they occur at the same temperature. Although they occur at the same temperature, thermal energy is it lost or gained? Absorb. So we gain the thermal energy, we absorb thermal energy during boiling. Okay, then for condensation, it is released. Does it make sense to you? When I was a student, I was a bit confused about when is energy absorbed and when was it released. When talking about formation and breaking of bonds, do you have that issue? Like if I ask you, forming of bonds, when bonds are being formed, is energy being absorbed or is it being released? Why are you also sure? Okay, so the opposite will be when bonds are being broken, is energy absorbed or released? Okay, so how to remember this, right? Is let's say your friendship, you also have bonds, right? If you want to break that bond, just an analogy, okay? If you want to break that bond, you need to have an energy, some energy to break that bond. So energy will be you need to absorb the energy to break the bonds, okay? So this is how I try to help myself to remember. When I break the bonds, it will have to absorb energy. So the opposite must be true. When I want to form bonds, I will release energy. Okay? Just use whatever method, whatever analogy that helps you remember this. So boiling takes place at a constant temperature or a fixed temperature for different substances. So what about this change of state from liquid to vapor at any temperature? There is evaporation, and during evaporation, thermal energy is removed from the liquid, causing a cooling. That's why when we perspire, and then you sit under the fan, you'll feel much cooler. Not all, some of the moisture on your skin evaporates. And because it evaporates, what causes it to evaporate? The gain in energy, right? So when it gains energy, it can change its state. So how did it gain energy? It must have gained from somewhere, and it gained from you. That means you lost thermal energy, and that's why you feel cooler. So over here, why do we perspire? Why does perspiration help to keep us cool? Gaius, do you get it correct? So how do we help ourselves remember this? This is physics. It is very practical. We experience this. So every time you perspire, then you feel a bit cooler. Then just do a quick mental recap on what's happening. The evaporation, why does it cool you down? Because there's a transfer of thermal energy from our bodies to the sweat. And as the sweat evaporates, it draws this energy and your body loses heat. That's why you keep cool. So part B, very similar. Babies are sponged with water when they have a high fever. That means you want to bring their temperature down. So still on evaporation. Zafan, exactly the same. You wrote the textbook. You wrote the textbook, is it? So where do you get the answers from? So do you understand what's happening? What about the previous few chapters? Work, energy, power, as well as kinetic model of matter. Did you understand what was happening? For those two chapters. Because I thought you understood. That's why I was very surprised by your test results. Finally, after doing the laundry, we spread the clothes out to dry. It's observed that the clothes that are well spread out dry faster than clothes that are not. This is a primary school question, right? You've learned this before. It's got to do with the surface area. Done? Okay, final page. Heating curve of water as time increases, temperature increases. Okay, that is for the region A to B. Then from B to C it is flat, indicating there is a change in state. Now, which portion is it a purely liquid? AB, because temperature is increasing. Mixture must be BC. Boiling point of water, 100. That is when the change in state happens. Okay, so the last one, explanation. Go ahead and compare all these answers. Find the similarities between these answers as well as what you have copied earlier in earlier questions. And in worksheet 9A also.